Welcome to the Modern Application Development Screencast. In this short screencast, we will learn how to connect and query a database using SQLAlchemy. Before we start, open the following applications on your Ubuntu desktop so that you can work along with me. Browser, preferably Firefox, Chromium or Brave is also fine. Gedit text editor, any other text editor would be fine, but Gedit comes by default in your Ubuntu. Terminal or default terminal is fine. Please also make sure that you have Python 3 installed on your machine. We would also need a DB browser like we saw in the last SQLite screencast to manipulate the database and work with it. In simple words, object relational mapping is a technique that allows the developer to query and manipulate the databases using object-oriented paradigm. So accessing the database becomes as easy as accessing classes and objects in Python. There are many toolkits available in Python world. Some of the known ones are, for example, PV. It's quite small and expressive. There is another one called Pony, and of course there is an SQLAlchemy. The most common one is SQLAlchemy. SQLAlchemy exposes a standard programming interface that is database agnostic. This helps us to write database agnostic code, which means if you write code for one database, you should be able to change the database and it should still work in most cases. Let's start with our experiment. We have a folder called experiment -SQLAlchemy. I have opened the command prompt. I've already cd'd into that folder, right? And I've got the database from our last experiment opened, and in DB browser you can see it's the same database, and it's the same database here. And I have a main.py which I've opened in in a gedit, which is empty. We are going to use this database that we created last time to experiment. We're going to use the same tables that we created last time. If you are not seen that, please watch it before you start this. Okay, let's start with creating a virtual environment, right? I'm just going to paste the code to create the virtual environment. I'm guessing you already know how to do this by now. Right, it's already created. Now we need to install SQLAlchemy. You can go to sqlalchemy.org, see the latest version. Here is the latest version 1.4.23. You can also go to PyPy site and see the latest version of the package. And here is the installation command. I think latest version is 1.4.23. We'll use the same thing. I'm just going to copy this and install. Before we install, we have to enable the virtual environment. So I'm just going to source it. Bin activate. So it's sourced now. Now I'm going to install SQLAlchemy. Might take a couple of minutes based on your internet connection. It's installed. Okay, I'm just going to clear. It's installed in our virtual environment. Now we're just going to edit the main.py and do our experimentation. Before we start, I'm just going to paste some of the imports. Instead of pasting one by one, I'm just going to paste some of them at once, right? Here I'm just importing some of the classes that I require to do the experiment. Before we begin, actually, we need to start writing the models for the tables that we have. That will be the first step. So I'm just going to get the base class for the model and write models for all our tables. Like if you go to our database, we have three tables: article, article authors, and user. Article is which contains article, user contains all the user, article authors contains a link table which is between the article table and a user table which has the article authors. it's a many-to-many relationship between article and user, like you can see here, article ID and user ID, right? Now let's create the models for it. I'm just going to paste it and take you through it, right? Let's write for the user first. Here, this is the user model. It extends the base, and then the table name is given here. This should be the same table name as in your database, right? Here, this user in lower caps, it's the same thing here. This could be anything, the class name could be anything. I'm just going to use the capital or camel cased user, right? And it has 3 columns. As you can see, user ID, username, and email. I'm just going to use the same name as in the database, right? And then we are defining the column as integer, auto increment is true, and it's a primary key. Similarly, username is column, it's a string or a text, and uniqueness is equal to true. Similarly, email, it's a string and uniqueness is equal to true. You can double check it here. Go to modify table. Yeah, here this should match. User and user, so table name matches. User ID auto increment true and primary key correct. Username is unique and email is unique. Username is unique and email is unique. So created for user. Now let's go ahead and create for article, right? So here is article. Let's open this table details as well, right? So here it is. You can see it has 3 columns: article, title and content, article, title and content. This is integer and auto increment, primary key. You can see it here. It's defined here. You can also see it here. Same thing we should define it here, right? Now the next we are going to define this article authors. Article authors extends base, table name is this, user ID is a foreign key to user.userid, this, and it's a primary key and nullable is equal to false. Similarly, article ID is a primary key to article table here, and it's a primary key true, nullable is false. This is a composite key because both are primary keys. Now this is done. Now we have to define many-to-many relationship between users and articles. Basically, whenever I get article, I want to get users too, so we can define many-to-many relationship. There are many ways to define relationships in SQLAlchemy. You can go to the page here and in 1.4.23 version and go to basic relationship. You can see how to define one-to-many relationship. Here you can see there's a parent table and a child table. Parent table has a children, which can be many children. Children by default is many, and then parent ID is only one, which means a child can have only one parent, but a parent can have many children. Similarly, we can check other things. Many to one would be same thing. You can define other interesting is many to many. Here, if here is the definition of association table, which we created separately. Actually, in our case, we don't have to worry. And then the relationship is managed. You can see that relationship is managed here. Children is through a secondary table called association table, right? Because in this case, a child can have many parents, at least 2, right? So now in our case, an article can have many users as authors, right? That's what we are trying to do through this table. So we can define a relationship here saying authors linking to user table through a secondary table called article authors. So this will be many-to-many relationship. It can have many authors, and it can have a relationship user, and through a secondary table. You can also similarly define articles here, and this can link to this table. Basically, it will link to all the users' articles linked through article authors. If you really want to, whenever you want to get user, you can also get articles. Similarly, now whenever you get article, you'll get all the authors. It's left us. I'm just going to remove this because I don't want it to get all the articles related to user all the time. Right? Only this relationship I want to maintain, because whenever I get an article, I also want to get authors. Right? Now let's start our real experiment by connecting to a DB. Right? In SQLAlchemy, you connect to a DB through an engine. Let's see here. Yeah, an engine connects a pool and dialect together to provide a source of database connectivity and behavior. As you can see here, an engine has both pool and a dialect, and it gives both of them for you to query against a database. You actually get an engine by calling create engine function and passing the database URL. Now the database URL will be of the format this, right? It will be dialect plus driver colon / username colon password host colon at the host colon port / database. In our case, we are going to use SQLAlchemy, SQLite. So there won't be any host or port. It will be just part of the database. So let's try to do that. Create an engine right here. So here I've not given any driver, so you don't see any plus PySQLite or any of the drivers. It's going to use the default driver which is installed. So I'm just going to remove this. It will be SQLite colon / this is relative path of the database. Since it's in the same folder, it will be ./test SQLite3. Now this engine will give us a connection pool and dialect to talk to this database. Right? Now we can run a connection. We can get a connection and run a query. Let me show an example here. So here you can see that I'm creating a statement to run against a database, which is a select statement on user table. This is how you generally write the select. I'm just printing it for our own reference. Just going to make it clear. All right, and then I'm just going to print the okay. So here I'm just going to create a statement. I'm just going to create a select statement from user table, and then I'm going to print the statement. Then I'm going to get a connection using engine.connect. It will give me a connection. Using this connection, I'm going to execute this statement here, and I'm just going to print the rows of the result. Right? We could split it into multiple statements, or you can use with combined statement here. And I'm just going to run this. Right? I'm just going to run it again. Okay. You can see here. It's printing the statement, SQL statement, which is a select star or select each column from user here, this statement, right? And then it's going to get a connection, right? And then run the query get all. Since there are 2 rows in our database, in the article, which table are we trying to get? User table. In the user table, there are 2 rows. We are actually printing 2 rows with all the columns, right? That's how you actually get a connection and run a query. Now you could have made it simple, I mean, if you really wanted to separate it out, you can just get a connection separately, get results separately, and then iterate through it. as well. I've just combined all of them. This is like ideal way of doing it. Now, usually we don't try to get connection every time. We actually create a session and then use a session. The session establishes all the conversations with the database and represents a holding zone for all your objects that you are loaded or associated with this ORM during the lifetime. Let's go to the session page and see the details here. When you take a little bit of time and then go through it. There are many uses of session. We'll go through a couple of them now. Let's run a query using a session. First, you have to get a session, right? And you get a session using a session object, session class, and passing the engine to it. Right? Let me just paste a piece of code and show it to you here. Right? Here, I'm getting a session by passing the engine, which has connection pool and other things. And then I'm trying to get articles. Here, session gives a function called query, and that you can use to query things. Here, let me explain this, what is happening here. I'm just querying the article table, then filtering the rows by article ID is equal to 1, and then getting all those filtered articles, right? And then I'm iterating through those articles and printing the article title. And then for all the author in article authors, I'm printing the author name. Like I explained, authors is a relationship. As soon as we get article, in this case, it will also get all the related articles using this relational table and load it into the array, and then I can directly access like an attribute against article and print them. The username is part of author, so I'm just printing the username. Let me run this, right? Just going to clear, right? It's printing hello world, Tejas GN and Raj. Hello world is the article title, and there are two authors. I'm just going to make it clear by printing in a better way. And I'm just going to make this also format well so that it's easy to read. Okay, I'm just going to save. All right, you can see that article is hello world, author 1 is Tejesh and author 2 is Raj. Now you can also make it to article 2, right? Let's check if there's another article. There's no another article. If we insert an article, let's add an article to H2 content. Okay, I'm going to save it. Then I'll go to article authors and add an author to that article 2, and the author is 2, right? That will be Raj, right? So now let's go back here, change into 2, correct, and then run it again, right? Now it changed, article H2, author is Raj, right? And there are many functions and many ways to query. We can go to querying part and see many of the operators available, and how do you do joining and left join, right join, inner join and outer join, etc. on this thing. And it's straightforward. For example, let's see if there is an example here. Okay, so here is where actually we are filtering by multiple conditions using an AND, right? You are importing an AND, then making sure both username and user full name is this. This is how you run AND. And if you want to get only one record, you can say .1, etc. And then there are joins, and you can use the joins to query as well. Like for example, here they're joining user table and address table. using IDs across them and then filtering by email address of the user. This is how you write joins. And there are many other options available. I think you should just explore this page on your own and learn about various ways of querying. Now there's another use of session, that is using session you can create transactions. Transactions is a unit of work you want to either completely be done or you want to completely roll back. You don't want a piece of work to commit into database. Let's say you have 3 or 4 steps to do. In our case we have 2 steps. First we save the article and then we save the authors of the article. If after saving the article, if something happens and article authors doesn't get saved, then we'll have this random article with no authors. We don't want that to happen. So ideally we want both the queries to run, both the inserts to happen or nothing to happen. Let's see a general case of it and then the error case handling of it, right? I'm just going to write a piece of code here. So here I'm creating a session with auto flush is equal to false. Auto flush is flushing in SQLAlchemy is a way to send the commands to the database and make it execute. And then here I'm making it false by default, so we can manually call it. By default it is auto. I'm creating a session, then I'm actually creating article and adding that article to the session, which is which is going to insert an article, and then session.flush, I'm sending it to the database now, and then it sends me back an article ID, which is an auto incremented ID, and then I take this ID and then I'm going to insert into article authors, and then if everything goes well, then it goes to else part and commit. If something happens in between, then it goes to roll back a section in this except section, and then it rolls back and raises an exception again and then ends the program. Here is when, let me just make it clear. All right, so let's run this. Okay, just going to clear. Okay, so yes, so it got article ID, then it went into commit area and it committed. Let's assume if something happens here after getting the article ID and before we create and save the article authors, and because of that we have to roll back and the article shouldn't get saved, right? So let's just raise a dummy exception, right? I'm just going to raise a dummy exception here, right? And just I'm just going to call dummy error, right? As soon as the error happens, it goes to the except part and rolls back, right? Hence, even though we run it again, this shouldn't get inserted. Oh, let's just check whether the last time it got inserted, right? Actually, it has got inserted, right? So I'm just going to call this my dummy new article, dummy, right? Let's run this now. Okay, it threw an error. You can see a dummy error, and it came here. It's rolling back. It's printed rolling back and rolled back. Actually, this won't get inserted, right? So you can refresh it. It's not inserted. Now we can just mask this, which means there's no error again, and run it again. Yeah, there you go. Got committed and inserted. Now you can see committed and inserted. So this is how we use transactions to handle errors if the database transaction has multiple steps and you want to do many things before you commit everything at once. Ideally, we don't do this way. We use relationships to add the data into the DB in simple cases. Since this is a simple case, we could just use the relationship to insert. I'll show one of the examples. Here, I'm still making autoflash is false, and then I'm getting an author object. By querying the user table by filtering Tejas, he is going to be my author, right? And then I'm creating an article by passing article title and article content here. Now I need to insert article authors. Now instead of like last time inserting into article authors directly, we are going to use relationships here. We are going to add an author into articles authors attribute, and then save the article and then commit. Indirectly what it will do is it will actually commit article, then it will commit article authors based on the relationship, which is authors here, and based on the relationship it goes to article authors and inserts respective row and then saves it, right? This is cleaner, simpler, and Python query. This is what we meant by it's easier, almost feels like accessing Python things even though you're accessing database related stuff. Now let's run this, right? No exception and hence commit. So it's come here and then committed. Let's see whether it got inserted, right? Using relationship. I'm going to refresh. Here we go. It has inserted this. And now actually the most important thing is whether it has inserted this part or equivalent of this part, which is connecting this to this, right? And this title is user relationship. The article ID is 5. And if you go to article authors 5, it is linked to 1, which is, if you go to the user table, it is 1. And that's what we wanted here, right? You could also have done many, like let's run one more, right? Let's say author 1, author 2, and let's say this was Raj, right? And second, using relationship, I'm just going to give random thing, and you added one author, you can add another author, right? 2 authors, right? I'm just going to print the article ID. Okay. We can just compare it using this title, right? So here I'm doing the same thing. I've queried for 2 authors, and then I'm creating an article object. I'm adding 2 authors to that article and just saving it, right? Let's run it. Here you go, no exception, hence commit. Let's see what whether this article with this title got inserted, right? Article, right? It got inserted. Second, using relationship, and its article ID is 6. Let's go to article authors 6. You can see there are 2 relationships. All right, it's quite easy to do using the relationship, and both querying, inserting, even deleting for that matter. So this is the end of this small introductory session to SQLAlchemy and generally the concept of ORM. There are a couple of things that you should remember. One, how to get the database URL. In our case, it's straightforward because we are going to use SQLite. It's just the path of the SQLite. Since it's going to use relative path, you have to start with a slash and use this / for the local directory. Usually it will begin with SQLite : ///. We are not giving any driver name, it is using the default driver name. Then if you already have a database, you have to write the models for the database, extend the base class, and then add all the models. Now you're going to use the same name as the column name for the attribute name, give the specific column types here and all the conditions here, and also make sure that you establish the relationship the way you want it to be. If you want more details, you can go to this page and learn a lot about relationship. Be clear to learn about at least 4 types of these relationships: one to many, many to one, one to one, and many to many. Yeah, all of them are useful. You will use them on day-to-day basis when you are accessing. The third thing is how to create a session. You create a session by passing the engine. Engine has both dialect and the pool connection pool. You will create only one engine in the application context, and then you pass on that engine to the session and use the session to do all your stuff. Use the ORM way to do it. Use object relations to create or delete objects, right? And then use the query on the session to query the database. You should actually go to this page, which has many examples on querying. There's a whole section on querying many ways, including all kinds of joins, external and internal, and doing tops and operators like equal, not equal, like operators, etc., etc. You should try most of them. It's straightforward to try with the given example. And then you learn about sessions and transactions, how to begin, how to commit, how to roll back. This is how we handle errors when you're dealing with databases. That's it actually. If you know these many concepts, I think you're kind of ready to jump start into using ORM in your application. This is in a standard way. We're also in the next coming sessions, we'll learn how to use it with a web application. Thank you for watching. Bye-bye.